This video is to illustrate 3 different algebra skills that we need in the work that we'll do this semester. This handout's also available online with all 3 problems, and then it follows up with 3 similar exercises for you to try. So if you feel like you need the practice with algebra, I certainly encourage you to do that. The first problem here reminds us about the algebra of polynomials, things that are just the variable to a power. The easiest way to do these is, in each case, we're going to be simplifying an expression that involves the formula that we're given for a particular term combined with the formula for some previous term. So here, for example, we're being asked to simplify the subtraction a sub m minus a sub m minus 1. So the easiest way to do that is just write them down first separately and make sure they're simplified individually first, and then combine them and subtract and simplify, and you'll find it a lot easier. A sub m is easy because our formula is for a sub n, and so a sub m would be exactly that same thing, just with m instead of n, if I can write that. So a sub m just is the same formula that we start with, but with m instead of n. A sub m minus 1 would mean to take the formula that we're given and change each of the 3 n's that you see. So a sub n, 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 change each n to be m minus 1. So if I change n to be m minus 1 here, it says this side. And then if I change n to be m minus 1 here and here, I want to be careful that initially I carry some parentheses with that, because the idea, when you just have a single variable like this, the n is the subscript, and so this means 3 times the subscript. If the subscript is complicated, it's still 3 times the whole subscript. And so that's why we're doing this. The subscript is m minus 1, and I want to make sure that I'm saying 3 times the entire subscript. Okay, so this could be simplified. M minus 1 squared, don't forget, I'll put over here, don't forget when you see a power of something like that, algebraically, that means that we're taking m minus 1 and multiplying it by m minus 1. And to do that, we need the distributive property, which you might remember as FOIL from high school. But each of these gets multiplied by each of these. And so you end up with 4 terms. So I'll have an m squared term, I'll have a m times minus 1, I'll have a minus 1 times m, and I'll have the minus 1 squared. So that's m minus 1 squared written out by thinking about the multiplication of m minus 1 times m minus 1. And then 3, well, let me just give myself more room here. And then the 3 distributes through those parentheses as well. And so I have that. So notice that what I'm doing is I'm making sure that I have parentheses to start with to correctly convey that the compound expression m minus 1 replaced n. But then my goal is to get rid of the parentheses. I'm going to multiply everything out, distribute everything I can, so I have no parentheses to look at. And now I can combine like terms. I have a minus m, and a plus 3m. And I have a plus 1 and a minus 3. So that's a sub m minus 1. So now the problem that says do this subtraction is just a matter of taking the expression I have up here for m squared plus 3m and subtracting, and I'm going to use parentheses again to make sure that I don't mess this up. I'm going to subtract a sub m minus 1, or I'm subtracting a sub m minus 1, but a sub m minus 1 we already know that simplifies to this. So that'll be easier just to put my final version here. So there I have a sub m, there I have a sub m minus 1, and I'm subtracting. All right, so now I got to get rid of parentheses once again. So the first parentheses aren't really doing anything. The second parentheses, those are parentheses after a minus sign, so this minus is being distributed through the parentheses. So it'll be minus m squared, minus m, and then minus negative 2 is the same as positive 2. Notice at this point that I have some stuff canceling out completely. The m squareds are completely gone. And I have 3m minus m is 2m and the plus 2. So the final answer here is that am minus am minus 1 can be simplified all the way down to 2m plus 2. All right, so now we're going to do one that has exponential expressions instead of just polynomial expressions. So here's a sequence definition where the closed formula has an exponential function, meaning that the variable is up in the power. We have a constant to raise to the variable power, which is a very different situation than we have when we had the variable raised to a number power, like 2. In this case, I'm not simplifying just the difference between the two. I'm simplifying a sub m minus 3 times a sub m minus 1. And there's a reason that 3 is there, and it's not a coincidence that the power of 3 is there. And we'll see that the reason that's there is because that particular expression simplifies more than other ones that I would use. So I'm giving you the algebra expression to simplify that has the most simplification that I can think of. So again, I'm going to do these separate. Let me just start with the first one again. This one's not interesting ever, but I feel like I should write it down to remind you what I'm doing. Taking the definition of the sequence and changing the n's into m's. So it's not exciting, but it is part of the problem. So I also need to calculate 3a sub m minus 1, and those are the two things I'm going to be finding the difference between. I'm going to take the first thing, subtracting the second thing. So let me just write this. The 3 is just 3, and now let me think about a sub m minus 1. Again, I'm taking this expression and changing the n's to m minus 1s. There's only 2 of them this time, so that's an n, that's an n. They both need to change to m minus 1. So I'll have 2 times 3 to the m minus 1 minus 5. So I don't have nearly as many parentheses to deal with as I did in the previous one, and I'm going to resist a little bit multiplying numbers together too soon, and I'll show you why in a second. So when I distribute this 3, through the parentheses, I'm going to let it go all the way to there. Okay, so just pay attention to what I did. I distributed this 3 inside, but I ended up putting it in between the two things. So I had the 2 and the 3 and the minus 1 there already, and I stuck the 3 in between. It's multiplication, so it doesn't matter what order it is. But the reason I'm doing that is because I know in my heart that something looks familiar about when I multiply two things together that have the same base. So I know that there's a rule for that, and I'll think about that in a second. But for now, I'm just going to put it there so that it reminds me that something can be combined. The other part of the distributive property here is this 3 multiplied by the minus 5. Okay, so what about this rule of exponents? It's not a very exciting rule, especially in discrete math, where we normally think of our variables as being not only just whole numbers, but in this case, our variables are always like 1, 2, 3, 4, 5, right? They're the actual subscripts of my sequence. And so in those cases, it's we can really just think about what exponentiation means. So for example, if I had 3 times 3 to the 4th, right, I'm not going to say what that's equal to. I'm going to say what it means. It means 3 times, and then 3 to the 4th literally means multiply 3 4 times. Right, so write down 4 copies of 3 and multiply them together. So that's what 3 times 3 to the 4th means. And so altogether, I have laid down a 3 5 times and multiplied them together. And so having 5 3's multiplied together, that's what 3 to the 5th means. So when I multiply 3 times 3 to the 4th, I just get 3 to the 5th. If we think of this 3 as being 3 to the first power, then you actually see a rule of exponents that you may remember, and that is when you multiply 2 powers of the same base, then you get another power with that same base, but the exponent here is just the sum of the 2 exponents over over where he started from. Well, this picture shows you why. The 3 to the first is 1 copy of 3. 3 to the fourth is 4 copies of 3. And so altogether, you have 5 copies of 3. So if you take 1 copy of 3 times 4 copies of 3, you're going to get 5 copies of 3. So it's not surprising, if you think about what it means, that should be the rule. But that's the only thing we have to use here. And that's the exponent rule that we'll see come up the most. So the reason I put those down next to each other is because when you multiply 3 to the first times 3 to the m minus 1, the powers should be added, and so I'll have 3 to the m. m minus 1 plus 1 is m, and then minus 15. I'm going to erase the stuff at the bottom, so pause and make a note of it if you want to. But now we're in a position to do the subtraction. So when I have a sub m minus 3, a sub m minus 1, I'm going to have the thing at the top minus the thing I found at the bottom. Right, so here's my a sub m, here's my 3a m minus 1. So I'm just going to subtract these two. When I let the parentheses fall away, just like before, that first set of parentheses is not really doing anything. The second set is following a minus sign, so I need to distribute that minus through the parentheses, which means I have minus 15. So just like before, that's plus 15. And just like before, I have some stuff that's actually going to add itself away. When we combine like terms, those things are gone. And I have minus 5 plus 15, so this simplifies to 10. So this expression actually simplifies to 10, so it has no m's in it at all. The m's are completely gone. All right, we'll do one more problem that involves fractions, rational expressions, because the algebra there also will feel a little different. So here we have an expression defined as the ratio of n over n plus 1, and this is different enough from what we did in class that it might be worth actually writing down some of the terms. So like a1 is 1 over 1 plus 1, a2 is 2 over 2 plus 1, a3, 3 over 3 plus 1, and so on. So that's what these terms look like. And the problem is asking me to simplify the expression am minus 1. So we now have this down to a science. I'm going to write down am just to remind myself of what I'm doing. I'm changing in my formula. I'm changing the n's to m's. Now I'm going to do the same thing, but this time I'm going to change the n's in the formula to m minus 1's. So again, I generally use parentheses when these n's change to m minus 1's. I usually take parentheses in with them. Notice I didn't put them on here. It's not necessary because this is the only thing sitting up here in the fraction. And you don't really think of it, but in a way, the fraction bar itself is like parentheses. Like whatever's above the fraction bar all goes together without having to put an extra layer of parentheses on there. You don't always think about that with fraction bars, but they are in fact they don't only mean division. They also are telling you how to group things. This expression is saying take m and divide by all of m plus 1. So the fraction bar both denotes division. It also is telling us what is bound together for the numerator and denominator. Anyway, there's not a lot of simplification that needs to happen here. Obviously, the denominator, m minus 1 plus 1, can be simplified, but that's all we can do. Be really careful. Don't give in to temptation and start canceling things like this. The rule for canceling in fractions is that you can cancel things in a fraction as long as the thing you're canceling is a common factor of the numerator and denominator. And I'm emphasizing the word factor because the factor is attached to an expression through multiplication. So that's why you can take something like 4 over 6, and you know that's 2 times 2 over 2 times 3. And because those the 2's there are multiplied, it's 2 times 2 and 2 times 3, that's why they can be canceled out. It makes sense because as I said, the fraction bar represents division, so multiplication on either side of a division seems like it would make sense to disappear because division and multiplication are sort of opposites of each other. It makes no sense to do that if the operation that connected that 2 or connected that 3 was a plus or minus. The logic would fall apart, and the rule does not work. It's easy to check. Just do the same problem with, 2 plus 2 over 2 plus 3. Right? You can canceling out the 2's does not give you an equivalent fraction. All right. So having said that, get rid of this stuff. I'm now ready to do my, well, sure, why not blue? I'm now ready to do my subtraction. So a sub m is this guy. A sub m minus 1 is this guy. And so it's really easy to write them down. Again, I don't really need parentheses because they already have their binding. There's nothing will happen nice from parentheses. I don't think I'm done with parentheses yet in this problem, but right now that's not, what I've written there is not ambiguous at all. Okay, so we need to subtract two fractional expressions. Well, the way that we subtract and add fractions is to get a common denominator and then just do the operation to the numerators. When the denominators are variables, have variables in them, algebraic expressions, then it's not too surprising that that we should use the least common denominator or use a common denominator that's just a common multiple of the two denominators, and the easiest common multiple is just the two things multiplied by each other. So m plus 1 times m is a common multiple of both of the denominators that I see, and so I could use that as my common denominator for the fraction. It turns out that is the least common denominator algebraically, but it doesn't really matter. And when you add and subtract fractions, a lot of times you're sort of have emphasized to you find the least common denominator, but it really doesn't matter. Any common denominator will do. The whole point is that you can't add or subtract fractions until the two fractions have the same denominator. So same denominator is the main thing. Okay, so to make the denominator of the first fraction be m plus 1 times m, I need to multiply the top and bottom by m. I know that as long as I multiply the top and bottom of a fraction by the same thing, then I have not changed the value of the fraction. So my original fraction is here, and I've multiplied in the top by m and the bottom by m. Because I've done multiplication there, this fraction has the equivalent value of this fraction. And then in the second fraction, I need to multiply the bottom by m plus 1 in order for it to have the same denominator here. And I'm allowed to do that as long as I do it to both top and bottom. So my original fraction would be like this. I'm going to multiply top and bottom by m plus 1. So now these two fractions have exactly the same denominator, which means that I can combine them using the subtraction operation. Subtraction is the operation here, just subtracting the numerators over that same denominator. So I'm going to make a big fraction bar. The denominator has m plus 1. I'm starting to relax a little bit with my parentheses. You'll notice I parenthesized everything just in case, and then I can sort of see what needs to happen. M times m is m squared. I have this minus sign, and now I have m minus 1 times m plus 1. That's another example of the distributive property where I have to multiply each of these things by each of these things. And all of that needs to happen while this minus sign is there waiting for the result. So to denote that, I'm going to put parentheses here so that I can do this operation and put its result here and not have to think about this subtraction sign yet. I'm just going to copy it down and then put parentheses so I know whatever's in here, all of it is going to get subtracted. So if you do m minus 1 times m plus 1, again, distributive property or FOIL, if that's how you learned it, will do that for you. And what happens in this weird case is because it's minus 1 plus 1, same number subtracted as added, then two of the four terms actually cancel each other out. You'll have a positive something and a negative same thing, and they'll go away. So try it and see, but what you should get is this. That's the result of multiplying m minus 1 times m plus 1. All right, so I'm almost there. I need to clear that parentheses in the top. So parentheses in the top, m squared minus, the minus sign needs to distribute through the parentheses. So minus m squared minus minus 1 over m plus 1. And once again, we can see that stuff's canceling. It shouldn't surprise you that things cancel. I'm going to always be asking you to simplify something that I know can be simplified. And so that's typically how that's going to look. And so we have 1 over m times m plus 1 is the final answer for the simplified expression.